going to work, so we're good. Okay, welcome to the CBE 2 review. My name's Kenna. This is Haley. We're tutors over in the tutoring center. We're just gonna run through all of the different problems that you'll see on CBE. So all of these, they obviously will be like the same numbers, but it'll be pretty much the exact same format as what you're gonna see on the CBE when you take it, or have any of you already taken it? Okay, yeah, so if you've already taken it, it'll look familiar. I mean, it looks the same as the review that you guys can do on Canvas, but yeah, as we're going through, just let us know if you want us to stop, if you have a question, if like we skipped over a step or anything like that, we're happy to go through it again. And then when we get to the end, if we have extra time, we're also like, we're happy to answer any more questions that you have to, or go over another example problem. So yeah, okay, let's get started. So the CBE is going to cover lessons 7 through 13, has polynomials, and then pretty much everything that you can do with a polynomial. Well, just not everything, but a lot of things like multiplying polynomials, dividing polynomials, factoring them, dividing them. We'll start with like an addition and subtraction problem. So lots of different things with polynomials. So first of all, just a couple of definitions. When we're talking through, a polynomial is a finite set of terms where each of them consists of a variable, which we usually use an x, and a coefficient, where the variable is the x and it can be raised to any power. So in this case, we have an x cubed. That's one of our variables, x squared and x. And then the coefficients are the numbers in front of the variables. And then the terms is the variable plus the coefficient, all of that wrapped together. And then the whole polynomial is the sum or difference of each of the terms. So, and then your degree is just the highest power in the polynomial. So for example, what is the degree of this polynomial? 3, gorgeous. So you'll just take whichever one has the highest power. If there's an x to the 5th and everything else is lower than x to the 5th, then 5 is going to be the power, the degree of the polynomial. So to start, we're going to subtract this polynomial. So what would be the first step when we're subtracting polynomials? Where are we going to start?
Would you like the negative one to like all of the ones in the parentheses?
Exactly. Yeah. So the reason we have parentheses around this is because we need to remember to take that negative and we're subtracting each of the terms that are inside of that parentheses. So I'll start by rewriting this. So 5m cubed plus 3m squared plus 4m. That's all going to stay the same because we don't have a negative in front of it. And then I'm going to take this negative and make each of them either negative, or since this 4 was already negative, we'll change it to be a positive. So that'll be plus 4m squared. Then this one will be minus m, and then this one will be plus 5. Does that make sense? Okay. So now, after we've distributed out that negative, where are we gonna, how can we simplify this?
You would like subtract your power of like m's, like m3
Mhm.
to the third minus m to the third and like m plus m.
Exactly. Yeah. So we can combine like terms, which means that all of the variables that have the same power, so all of the x or the m cubes or all of the m squareds or so on, we're gonna combine the variables or the coefficients. Sorry, I'm realizing that I definitely wrote a squared, but I am not able to find the eraser right now. So we're gonna scratch that out and that should be a squared. Okay, so like this, we have 5m cubed, and then we're gonna subtract that 6m cubed. And then I'm just rewriting this so I can reorder it. It's a little bit easier for my brain. I'm so sorry that I don't know where the eraser is. This iPad is being a little bit finicky today. Plus 4m squared. And then we have 4m, and then minus m, and then plus 5. So now we can just go in, now that we've reordered it, it's a little bit easier to see what we're actually adding and subtracting. So then we have 5 minus 6. So I have a negative 1m cubed. And then you have 3 plus 4. So you'll have a 7m squared. And then you have 4 minus 1. So you'll have a 3m. And then we don't have anything to add to the 5, so we'll just leave that as 5. Does that make sense? Hopefully that is the right answer. Gorgeous. Nice. Okay. Does anyone have any questions about that process? Cool. Okay. I'm gonna do this one.
I got it. All right, determine the value of the polynomial. So what we're gonna do here is we're just gonna plug that 3 in for every x that we see. So I'm just gonna rewrite it with a 3 instead of x. So I'll put that there. 3 times 3. And then subtract 12, okay? All right, and then what would I do next? What was that? Yes, exactly, to the exponent. So 3 squared is going to be 9, so that'll be multiplied by 9. And then we know 3 times 3 is 9, minus 12. 2 times 9 is 18. Okay, and then we've got 18 plus 9 minus 12. What would you guys like to do from here? Which one should we combine first?
It sucks. I'd put it add first.
You'd add first? Okay, 18 plus 9. It's gonna give us 27 minus 12. And then we get 15. Okay. Any questions on that process? That was pretty straightforward. Okay.
Sine or cosine?
Awesome. All right, so now we're on to multiplying polynomials. So multiplication is commutative, which means that the result is the same no matter like which way you multiply them. So over here it shows that like 3 times 5 is the same as 5 times 3. They'll both give you 15. And then the same thing with like a whole polynomial, multiplying a whole polynomial. So like 3x plus 7 times by x minus 1 is the same as x minus 1 times 3x plus 7. And then when we multiply polynomials, we use the distributive property. So just like here where we distribute a to b and c, here we're going to distribute the e to the gh, and then we'll distribute the f to the gh as it's kind of shown right here. Are there any questions on that process at all? We're good there? Okay, awesome. All right, do you want to do another problem?
Okay. So in this one, like she said, we're gonna start by distributing. So in this case, we'll want to distribute our 4y to each of these. And then after that, we're gonna distribute our 5 to each of them as well. So we should end up with 6 terms. So I'll write that like this. You'll have that 4y times 3y squared. And then I have another 4y times negative 3y. And then that 4y times negative 4. And now we're going to add that to 5 times your 3y squared again, plus 5 times negative 3y, plus 5 times negative 4. So it becomes a lot longer and complicated before it gets simple again. Do you see where all of those new terms came from, or we multiplied them out? Okay. So now we want to go in and simplify. So while we walk through this, will you guys just, I'm like very bad at doing algebra in front of other people. So if you want to just like tell me what each of the terms are going to be. So what is this first term going to end up being? Right here. So we'll multiply these to the coefficients and then also multiply the variables. When you multiply variables, you just add their exponents. So we'll have 12y cubed, and then what's this next one going to be? So we'll have 4 times negative 3. And then this next one will have 4 times negative 4. So that'll be negative 16. And then we only have one y, so we'll leave that there. This next term we have 5 times 3. So we'll have a 15. And then we only have that one y term, so we'll have y squared. Then 5 times negative 3, so I have negative 15 y. And then our last term, we don't have any y's, so it's just 5 times negative 4, which is 20. Gorgeous. Okay, so now from this step, where will we simplify?
You just combine like terms.
So we only have one y cubed term, so we'll keep that the same. And then we have our negative 12y squared plus 15y squared. So that's going to end up being 3y squared, right? And then we have that negative 16y minus 15y. So that'll be negative 31y. And then we just have that one constant term, so there's no other ones that don't have a y. So that'll be negative 20. Gorgeous. I love it when the answer is the same as mine. Okay, cool. Does anyone have any questions on that process? Okay, awesome. Sweet. Oh, one more of that.
All right, so this one is asking what the area of a rectangle with width 3x minus 8 and length 2x plus 7 is. So the first thing I like to do on this kind of problem is I like to draw a picture because I don't know, I do better when I can visualize it. So we have our rectangle and we'll set the width equal to 3x minus 8 and we'll set the length equal to 2x plus 7. And then it gives us the formula for area right here. So we know that the area is going to be equal to the length times the width. So what do you guys think is going to be our first step here to find that area?
You just put them in parentheses next to each other.
Exactly. Yep. Exactly. So we'll multiply them together. So we're going to take 2x plus 7 and multiply it by 3x minus 8. So we got our length on one side and our width on the other. Okay, and then we'll do exactly what Kenna did earlier. We'll distribute this one to here, and then here, and then we'll distribute the 7, the 3x, and the 8. So 2x times 3x is going to be 6x squared. And then 2x times that negative 8 is going to give us a negative 16x. And then 7 times 3x is going to give us 21x. And 7 times 8 is negative 56. Is that right?
Yes.
Okay, perfect. I also struggle with algebra in front of everybody. So.
Yeah, I'm like,
Okay.
I swear I've been doing that for a while, but also if I add things wrong, please tell me.
All right, and then here, there's one more thing we can do to simplify it. What do you guys see that we could do?
Just combine negative 16 and 12, 21.
Exactly, yep, combine those two like terms. So we get 6x squared. I believe it's plus 5x minus 56, and that should equal our area. And then let's double check that that's right. Sweet. Okay, any questions on that process? We're good there? Okay, awesome. All right, I'll let you describe dividing.
Okay, so now we're gonna move on to dividing polynomials. So there's two main categories or different situations you'll run into when you're dividing polynomials. Either you'll be dividing a polynomial that has multiple terms by a monomial, which just means there's one term, still has coefficients and a coefficient and a variable. So when you're doing that, you'll just split up the terms on top. So it'll look something like this. You'll have like an x cubed minus x squared plus x or whatever is going on. And then you'll just have maybe an x on the bottom. So you'll split that up into individual fractions where you take each of these terms and divide it by x individually. So it'll be x cubed divided by x minus x squared divided by x and so on. So when it's a monomial, it's simple to just, you're allowed to just break up the top into its own little fractions. You can't do the same thing if you're dividing a polynomial by another polynomial, because you're not allowed to break up the denominator. So this works because there's only one term in the bottom. If there's multiple terms in the bottom, then you have to use long division instead. So if you have something that's set up like that, or you have x squared plus x plus 1 over x plus 1, you're not allowed to break them up one by one. So we'll put this in long division form like this, x squared plus x plus 1. And it's pretty similar to when we did like long division just with regular numbers. And we'll just go one term at a time, and we'll run through a couple examples where we're doing that. And what you're gonna end up with is a term on the top and then a remainder down at the bottom. And what you'll write down is this term on the top plus your remainder over what you were dividing by. And that'll be your final answer. So this is a really important step that it's really easy to forget about, because we like to look at our number on the top of our division and say, okay, this is our answer. But if you have a remainder, you need to make sure we add that to the end. But yeah.
If we don't, do we just put 0?
If there's not a remainder, then you don't have to add anything to the end, because it'll be the same as just 0 over, like 0 divided by this, if your remainder was 0. So yeah, so you can write the 0 over that, but it'll be the same as just not writing anything. So I think that the software will accept either way. Yeah. Okay. So for this guy, which situation is it? Is it a monomial or a polynomial on the bottom? Monomial, yeah. So we just have the 1. So we'll just break it into individual fractions. So we have 9x to the 4th. We'll divide that by negative 9x to the 4th. Then our next one is going to be that negative 6x cubed over negative 9x to the 4th plus 5 over negative 9x to the 4th. So however many number of terms you have on the top is how many fractions you're going to end up with that you'll simplify one by one in the end. So how are we going to simplify this guy now? So let's look at just this first term right here. How can we simplify that?
Wouldn't that just be -1?
Yeah, so a lot of the times, because both of the 9s will cancel out and these x to the 4th will also cancel out. So that means all you're left with is -1. And then this next term, let's look at the x's first. So how many x's are we going to be left over with? And is it going to be on the top or the bottom? Exactly, yeah. So we cancel out all of those and we're just left with 1x down here. So we'll have 1x on the bottom. And then what about our coefficients? How will those cancel? Or how do they simplify, I guess? How could we simplify 6 over 9? We're looking for common factors.
Just divide them by 3.
So if we divide both of them by 3, this one will be 2 and this one will be 3. So we could write that as 2/3. And then these negatives are going to cancel out too, so we don't need to add any negatives back in. And then on this last term, what about our x's? Can we cancel any x's? Okay, so we'll keep that x to the 4th in the bottom. And then what about 5 and 9? What common factors do we have there? Yeah, so this one can't even really simplify. So we'll just keep this as 5/9. And then I'll bring that negative that's in the denominator out to the front because the negative isn't canceling. Sweet. Awesome. Does anyone have any questions with the monomial process? Okay, cool. We're gonna do one with a long division now.
All right, so long division, we'll set it up just like she did earlier. So we'll go over here so I have more room. 3x cubed minus 7x squared.
Yeah.
Yep, yeah. Plus 5. And then we'll have our x minus 4 that we're dividing by. And so I kind of jumped the gun on this one. Why can't we use the monomial method on this one? Yeah, exactly, because there's 2 terms in the denominator, so we have to use the long division on this one. Okay, oh, and there's one more thing. So we are missing an x raised to the first power. So to keep it organized, I like to just add a 0x raised to the first power plus a 5. It doesn't change it, but it will just make it a lot more organized when we go through the long division, okay? Does that everyone get that step? Is that step fine? Okay. So what do we need to, I guess, how do we go about this first? What would we do first here?
Don't you just figure out like what times x equals 3x to the third?
Exactly, yes. So what times x will give us 3x to the third?
Yes, to the second.
So we'll start with the 3x squared, and then we need to multiply this by what we're dividing by. And we're left with 3x squared. And then we got to multiply 3x squared by that negative 4. And that'll give us a negative 12. Oh, this is cubed. I'm sorry, guys. That's cubed. This one's squared. Okay. Are we good to that point? Yes. Okay, awesome. So we're going to subtract this from above. So 3x cubed minus 3x cubed is just going to give us 0. And then this negative is going to come into here, and we'll add the 12 to the negative 7. And that is going to give us a positive 5. Yep, 5x squared. And then we'll pull down our terms out here. Okay, we get to that point? Awesome. All right, and then we're going to do the exact same process again. So what are we going to multiply x by to get us to this 5x squared term? Yep. So we'll put 5x up here, and then we'll multiply 5x by x to get a 5x squared, and then multiply 5x by negative 4 to get a minus 20x. Subtract 5x minus 5x is 0. This negative is going to distribute into here, and we're left with a positive 20x. We'll pull down that 5. Okay, now we got one more to do. What will we multiply x by to get this 20x? So we'll add 20. 20 times x is 20x, and 20 times negative 4 is going to give us a negative 80. We'll subtract again. 0, negative distributes, so that 80 will be positive, and we're left with a positive 85. All right, so now I don't have any more terms to pull down. What do I do from here?
You just put add the 85 over the x squared to the top equation.
Exactly. Okay, and that should be our final answer. Okay, awesome. All right, what are you guys' questions on that? Do you have any questions? We're good there? Okay, awesome. Factoring. Okay, so factors are the numbers that multiply together to make a number. So we can kind of think about it like undoing multiplication. So in other words, we're going to look at what divides evenly into our number and then write it as a product of those divisors. So we've done a little bit of factoring, like if we have the number 6, it factors into 3 and 2, right? So it's going to be very similar to that. We're just going to do it with polynomials now. Okay, and then the greatest common factor is the largest factor a group of numbers all have in common. Okay, so if we had like 6, 12, and 18, what would their largest factor be? Be 6. Would it be 6?
That's the least common multiple.
That is the least
Yeah.
common multiple.
Mhm.
So this is the least number that we could multiply.
That'd be 6.
It would be 6, yeah,
Mhm.
because this one can be represented as 6 times 1. This one 6 times 2, and this one 6 times 3. Exactly. Okay. We're good there. All right, I'll let you explain this.
Okay, so when we're factoring trinomials, this is just a polynomial that has 3 terms. So most of the time it's going to be an x squared, an x, and a constant term. We first want to start by ordering them in descending order, and then you want to unfoil. So pretty much you want to take it from being like 3 terms to 4 terms, and then you can break it up into the 2 things that you like foiled it out. Does that make sense? It's just going backwards. If the leading coefficient is 1, then we want to figure out what 2 numbers multiply to the last or the last term and add to the middle term. And if the leading coefficient isn't 1, the first thing you'll try is just factoring constants out so that you can get the first term to be 1. If that doesn't work, then you multiply the coefficient on the first term by the constant term, and then you do the same process that you did with, if it's 1, you figure out what 2 numbers multiplied to that or add to the middle number. So it's a lot of words, but we're going to go over all of the examples of these. But I think that you guys have seen most of these kinds of things before though. So you want to start by factoring this one. So which situation is this? So what is or I guess what's the coefficient on our first term?
1.
So since it's 1, we can just go ahead and look at our middle 2 terms. So we want to figure out what 2 numbers multiply to equal 2 and also add to -3. So yeah. What can you guys think of? This is like the puzzle part where you just kind of trial and error until you figure something out. Okay, so 2 times 1 equals 2. And then 2 times 1, that doesn't equal -3 quite yet, it equals +3. So what would we have to change about it? Yeah, we would have to make both of them negative. And that still works up here because a negative times a negative is a positive. So a lot of the times it's kind of playing with negatives and figuring out which combination will work. So when we figure that out, now at this point, we can just rewrite this. This is always going to be equal to x minus 2 and then x minus 1 once you found those 2 numbers. So it's super easy when you have a 1 as your coefficient on your first term, because once you've found your 2 numbers, you can just plug it into the factored form. So this should be our answer right here. Gorgeous. Okay.
Okay. So in this case, what is our coefficient of our first term? 8. So we have to do something before we can factor, right? Which ones? So what do we do from here, I guess? So we'll multiply the 8 and the 1 together, which of course is 8. Okay, so then we're going to be looking for 2 things that will add to 8. And we'll multiply to 6.
It's the other way around.
Oh gosh. Yeah, you're right. Sorry guys. That's a multiply. That's an add. That would make a big difference. I was like, is there anything?
I was like,
okay, can you guys think of anything that would work for this?
2 and 4.
2 and 4. Okay, let's try it. 2 and 4 do multiply to 8. And 2 and 4 add to 6. Perfect. Okay, so what would we do from here?
Just split the 6 into 2
Exactly. Okay, and then we'll group them, right? And we'll pull out all the common terms we can find. So in this first group, what could we pull out of both of those terms? 2 for sure. And an x, yep. So then we will be left with 4x plus 1. Okay, and then in that second group, it's already in that 4x plus 1 term. We can't really pull anything else out of it, so we're going to leave it there. Okay, awesome. So now what do we do from here?
You would add like the 2x and then make that its own thing.
Mhm.
You would just times that
Exactly, yep. So we're gonna pull out the common term here. So we're gonna pull out a 4x. And so we'll have a 4x plus 1. And it will be multiplied by that 2x and that 1 right there. Okay, and that should be it. Awesome. Okay, any questions on that one? Okay, great. All right, so now we're going to talk about factoring by grouping. So we factor by grouping when there are 4 terms, and then we can group together different terms to factor something out from just that group. So it's really similar to what we just did. We're just going to have an x to the 4th power now, I believe, or third power.
Yeah,
Somewhere around
and I
there.
mean, we technically did just do factoring by grouping.
Just barely, yeah.
Yeah,
So that's literally
it's
what
literally,
it is.
yeah, that is literally what we did. And some, and like the ones that we'll see, like you might have other terms on your x, it might not be a trinomial to start with, but like,
Yeah. Okay, and then typically there would be 2 groups that can factor to at least one of the same factors. So then we can use the distributive property to factor further. So just like we did when we pulled the 4x plus 1 out of both terms. All right.
oh yeah. In this case, a lot of the times, the reason that it has to be factoring by grouping is because you have multiple variables, which is why it couldn't be written as a trinomial. So, sweet. Okay. So for this one, we want to start by grouping them. When there's a negative term in the middle of my group, most of the time I'm gonna rewrite it so that I can, because this negative is only connected to the 7, it's not connected to the whole thing, so we don't want to let that go outside of our parentheses. So I'll rewrite this as axy plus 56y. And that's our first group. And we want to add that to our second group, and then I'll put that -7 on the inside, just so that I remember that that's only connected to the 7. Because a lot of the times, if I just like go in and write parentheses, then I'll think that the negative needs to be distributed in. But you just want to make sure you add that plus in the middle of the terms. Okay. Does that make sense?
Yeah.
That's just something like notationally that sometimes messes me up, but okay. So in this first term, what could we factor out?
81.
Gorgeous. Is that 8? 7. Thank you. The one thing I'm not good at is my multiplication tables. Okay, and then this term, what could we factor out? X, and then that's gonna be a +7. Gorgeous. Okay, and now that was perfect. We don't even have to keep looking for things because our x plus 7s match. So like Kaylee did, we're going to pull these guys. We're gonna factor them out to the front. So that's gonna be our x plus 7. And then we just write whatever is left behind, basically. So we have that 8y minus 7. Yeah. Gorgeous. And that should be our answer. Okay. You guys have any questions about that? Sweet. Okay, so these are just a couple of special factoring formulas. You don't have to have these memorized because you can use like factoring by grouping or long division or any of those kinds of things to figure these out, but they are helpful if you just know them off the top of your head. So they're good things to review if you want to be able to remember them, but don't be stressed about them because you can use your other what are they called? Other techniques to solve them as well. Sorry. But yeah, so you have your difference of squares. So if you have two perfect squares, those are the only two terms, and there's a minus in the middle, you can split those up into the plus version and the minus version. And then you have your perfect square trinomials. And so, yeah, they're just these formulas. If you have the -2 on your middle term, then you'll just switch it to a minus on the inside of the squared term. Yeah. So, yeah.
Yeah, you got it. All right, so now we're gonna fully factor this polynomial, okay? So before we start factoring, is there anything we can pull out of all three of those terms? What was that? A 5, yep. Then there's one more thing. 5x cubed. Okay, so 80 divided by 5 is going to be 16, I believe. X squared minus 8x plus 1. Okay, awesome. All right, so now we have that 5x cubed out in the front. Now let's look at our inside term here. What is the coefficient on the first term? A 16. So we have to multiply the 16 by the 1, which equals 16. And so we need to find something that multiplies to 16 and adds to -8. Oh, I put a multiply sign again. There you go. Okay, so what two things are gonna multiply to 16 and add to 8? -8. -4 and -4 will work great. Okay, and then we'll do the same thing. I'm gonna bring it over here so I have a little more room. 5x cubed, 16x squared, and then we'll break up that middle term, minus 4x minus 4x plus 1. Okay, and then from here, we're gonna group our terms together, and I'm gonna rewrite it just like Kenna did so we don't lose track of that negative. I'll put big brackets around this. So we got 16x squared minus 4x plus -4x plus 1. Okay, is there anything that we can pull out of this term? Yep, yeah, -4 and an x. And we could pull out a -4. I think I'm gonna pull out just a 4 so that first term can stay positive. So we're gonna pull out a 4x. I think either way should work though. Okay. And then the second term, what do we need to pull out of it to make it look like that first term? To make it look like this, sorry, this part. Because it's, yeah, exactly, -1. Okay. Now they look the same, these two terms do. So we're gonna pull them both out. And we will be left with 5x cubed times our term that we pulled out, 4x minus 1, times the inside terms here, 4x minus 1, which will simplify to 5x cubed 4x minus 1 squared. Perfect. Okay, any questions on that one? We're good there. Okay, awesome. All right, I'll let Ken talk about the Aggie Math Learning Center.
Cool, okay. That is all of the problems that we have prepared. If you want help with other, like as you keep reviewing for the CBE or future CBEs and homeworks and stuff like that, the Aggie Math Learning Center is right next door. Me and Keely are both tutors there, and the hours are over, they're posted on the door too. But anytime you go in, the tutors are gonna be super helpful. With this class, most of our tutors know it really, really well. And yeah, we also record all of these CBE reviews. So we have the ones from past years on our YouTube channel, which is on our website. You can just search Aggie Math Learning Center on Google and it'll pull up. And that'll also tell you when all of the future CBE reviews and stuff like that are. So as you're like going throughout the rest of the semester, just use this as a resource. If you ever have any questions, just come in and ask the tutors and we can help you find other resources and stuff like that, whatever you need. So yeah,